Right now. All right. Good morning, everyone. Thank you so much for attending this brown bag session. I will start with introduce myself a little bit. My name is Sijia Huang, and I am currently an assistant professor at Indiana University Bloomington. And it is such a pleasure to be able to share some of my current work and also some of my understanding regarding machine learning stuff in the field of education with you guys. And since we have a rather small group, I'd just make the whole thing a little cute discussion. So feel free to stop me if you have any questions or you have any interest in the stuff I am currently doing. Um, a little bit like introduction regarding my own research interest. I expertise in IRT. I do a lot of like stuff about IRT, for example, like extending IRT models to accommodate really complicated data structure. And I'm also working on some machine learning stuff and see how we can incorporate those super fancy machine learning, super fancy and also like very useful machine learning stuff into the field of education to address like certain problems that we are interested in. And I also work very closely with a clinical psychologist. And in the world of clinical psychology, the clinical skills are like so broadly used. And one of the topic, the projects that I'm currently working on is closely related to this line of my work, like my collaboration with clinical psychologists. And this is something that I really want to share today. So the project title is Uncovering Heterogeneity in Adaptive Functioning within Children with Autism Spectrum Disorder. And this is apparently the overall aim of this project. And to achieve this overall aim, we tried different approaches, like including the more like conventional or traditional model-based approach and machine learning-based approach. um, I didn't put that part in the title, otherwise the title will be super long, but we'll get there when I am introducing the methodology we are using to address this issue. So I'll start with the motivation, and since not many of you have like the background in clinical psychology, I will do something to set up the bigger context so that we are on the same page. Um, the Autism Spectrum Disorder, the ASD, is just one of the most prevalent neurodevelopment disorder. And according to the estimates from CDC, and in 2018, about 1 in 44 children in the United States have been identified with ASD. And you can imagine, given the like large population of children in the United States, this ratio can be really high. And there are so many kids that are diagnosed with ASD and are just in normal schools. And children with ASD would exhibit significant delays in adaptive functioning. And this adaptive functioning is like the key like content we're exploring in this study. And the adaptive functioning, just for example, include the communication skills and also daily living skills, which are really important. And the adaptive functioning is increasingly recognized as a critical component of diagnostic assessment and as a really important predictor of functional outcomes for like children diagnosed with autism. One thing that has been like acknowledged as a challenge for intervention development in ASD is that this autism spectrum disorder is characterized by notable phenotype heterogeneity. Um, for example, the developmental progression of adaptive skills will be very different among children diagnosed with ASD. With that being said, it means even though children may receive diagnosis of ASD, but in fact, their phenotypes, like the manifestation of that, can be really different, like from children to children. And uncovering this heterogeneity in adaptive functioning, which is what we are focusing in this study, like in children with ASD, is of both theoretical and practical importance. Like number one, if we have a better understanding about like what sort of like different profiles of adaptive functioning we have in the population, we tend to have a finer grade understanding of the autism spectrum disorder. And more importantly, and knowing what are the profiles of adaptive functioning will help us developing effective intervention plans and also a specialized curriculum. As I just mentioned, many children who are diagnosed with ASD, they are going to school and actually require special curriculum to facilitate their learning. So the idea is that if we know what are the profiles of adaptive functioning, we can like sort of like design or just like making specialized curriculum to address their needs, which makes the curriculum themselves like very effective. So here comes the research aim. We are sort of like assuming that the population of children with ASD are just may consist of like several hidden groups, like groups that are like latent, and each of those groups will have a unique profile of adaptive functioning. For example, you can imagine the little figure here as the entire population of children with ASD. And with this little group, they have their own unique adaptive functioning profile. And with the other group, they have their own. And the idea is, in this study, we want to uncover this hidden adaptive functioning profiles. We want to know like how many like meaningful adaptive functioning profiles are there in a population, and we also want to know in each of those profiles what are the characteristics of those profiles and how we can make use of those characteristics of profiles to design either intervention plans or like a specialized curriculum. To achieve that goal, what we're going to do is to cluster the children with ASD based on their responses to multiple items of a measurement instrument. And this part may sound, I guess it will be super familiar to you, that we will be making use of categorical responses to items in measurement instrument to cluster ASD children. And the children with the same adaptive functioning profile would have similar item response pattern. That is the assumption, which makes a lot of intuitive sense. And while those with different group membership like will exhibit different response patterns. With that being said, we mean that children, if they are within this group, having a unique profile of their own, and these children who shares the same adaptive functioning profile would have like similar item response pattern. And while this little subgroup here who share the same adaptive functioning profile will have their own response pattern. And since the group membership, the profile themselves are not directly observable, we will be using the observed item responses to sort of like derive the latent group membership, and then to achieve certain goals that makes a lot of practical sense. That is the entire context and sort of like the substantive goal of our research. So here comes the fun part, the methodology we're going to use. So if we just rephrase what I have just talked about, the problem is kind of like translated to a issue that involves partitioning n children, where the big N refers to the number of total children we have, into k clusters, where the k is just number of clusters but are unknown. The number is not known before conducting the analysis. And this cluster task is complete based on measurements of like the children on V categorical variables. And the V just refers to the number of items in the measurement instrument. And since we're dealing with item responses, they are apparently categorical variables. And a quick introduction regarding clustering approach, which is sort of like the meat of this study, is that like the clustering approach can be either model-based or non-model based. The model-based clustering approach, like as its name suggests, is an approach that has a underlying statistical model. For example, since we are assuming the entire population consists of like several hidden groups, and we sort of like assume that each group they have their own model for generating that sort of like responses. And all the item responses of the entire population then can be viewed as a mixture of like several models, like several responses generating from different models. So with that being said, we are like kind of like assuming the observed item level data are generated from a mixture of distributions with different parameters. Well, we have like you can imagine we have small models for each of the subgroups, and then the entire observed data are made up of like different submodels. And this is sort of like more conventional or classical, say, model-based classroom approach. And the non-model based methods can be sort of like understand as more like a data-driven approach, because those approach typically do not involve any underlying statistical models. Instead, they typically correspond to discrete optimization algorithms that may seek to optimize a diverse range of objects. Um, as you can tell from like the categories, one category of approach will involve statistical model, while the other is more like data driven, like machine learning sort of like thing. And in this study, we are sort of like uh, it, applying both type of approach and also see if these two type of approach will give us results that are similar to a certain extent. So for the model-based classroom approach, we'll be focusing on this latent class analysis. The latent class analysis is just a super well-known example of the model-based classroom approach. So what it does is that it partitions individuals to k mutually exclusive and exhaustive latent classes. And each of the classes has a class probability denoted here by lambda k. And since though we have that many groups, and the sum of the class probabilities will add up to 1. And the latent classes analysis is known as a like person-centered approach, as opposed to a logistic regression, which is sort of like known as variable-centered approach. We can see a little figure here, sort of like as a illustration of what this latent class analysis is sort of like to do. Yeah, I won't be able to provide too much technical details, but I think the figure illustration here should be sufficient to provide a basic idea about what this latent class analysis is trying to do. So again, we have this latent X, like represented by a circle in this diagram. It is a categorical variable indicating the latent class membership. And since we don't really know how many latent class are there, this X can be a variable that with like different number of categories. And one of the aim is to explore or to compare model with different number of classes and determine how many latent class we are supposed to be keeping. And also in this figure illustration, we have like 4 squares representing observed categorical variables. And in our case, it will be like item responses. And of course, we have more than 4, but figure illustration, we keep only 4 observed categorical variables. And the distribution of these observed categorical variable will be different across latent classes. So with that being said, we have for each of the latent class, we have a distribution model for the observed categorical variable. And then we mix everything together and to have the entire population data. For the non-model based clustering approach, and we're exploring in this study, we are focusing on the hierarchical cluster analysis, which is an unsupervised machine learning approach that can group individuals with similar features into clusters. And with this like unsupervised machine learning approach, we don't have really have the distinction between the X and Y, the independent or dependent variable. We don't have a specific variable that we're trying to either predict or classify. But with unsupervised, we're just group individuals based on the observed like responses. And in our case, they will be multivariate categorical. And this HCA, the hierarchical cluster analysis, have been successfully applied in a few ASD studies. And compared with some other really popular unsupervised machine learning approach, for example, the k-means, the HCA requires no predetermined number of k, and also results in an attractive tree-based representation of the observations from which we can determine the number of clusters in the entire population. Just a kind of like a quick introduction about what HCA is and how it works. So basically, it involves iteratively combining or splitting clusters based on their distance. And by distance, you can have like different definition for it. And we will get to that point when we are discussing the results and also the entire thing. And one of the strategy of clustering the observations in the data is the just bottom up, and the other strategy is a top-down strategy. And the bottom up clustering strategy just starts with treating each individual as its own cluster, and then fuse 2 clusters that are least dissimilar, which involves defining a similarity measure. And the fusing step is just repeated until there remains only 1 cluster. And to illustrate how it works, let's consider just a simple example with only 9 individuals and 2 continuous indicators. So since we have 2 continuous indicators and 9 observations, one thing we can very easily do is to just put the individuals in this 2-dimensional space, having the x-axis and y-axis be the 2 continuous predictor respectively. And here the number just represent the observation ID, and where they are just represent their locations in this 2-dimensional space. And we have this 9 observations here. This HCA strategy just starts with having 9 clusters, where the 9 is also the number of clusters. And then we'll be computing the distance just between different clusters. And in the first step, it's just going to be the distance among the individuals. And then we are combining the 2 clusters that are least dissimilar. For example, in this case, we have the 5 and 7 here clustered together. And while fusing these 5 and 7 observations together, they're creating a new cluster, and we end up having 8 cluster in after this step. And we keep repeating this and calculating the distance among different clusters and see how we can just put them together. And in this step, the third step, we have the observation 1 and 6 being the clusters that are least dissimilar. So we then combine them together and resulting a 7 cluster by the end of this step. And we keep doing this. And in this step, we are combining the observation number 8 with another cluster, just which consists of like observation 5 and 7. And by the end of like this step, we are having 8 clusters. And we just keep doing this until we only have 1 cluster. And this also gives us something called dendrogram, which kind of like show how different clusters, how the individual observations got combined with each other. And also the y-axis also show how far away each of these clusters are. And the number of clusters in the case of HCA are kind of like decided based on the dendrogram, since you can easily draw a line like here, vertical line here, and you will be ending up having like 2 clusters. And if you want to have more clusters, you can like draw a line at different places so that you will have like different number of clusters. And this is quite different from the approaches of k-means or k-medium, which requires you to specify the number of clusters at the very beginning of the analysis of the algorithm. Okay, and that's a very quick introduction of the 2 methodology, like 2 approaches we are using to achieve the overall aim to which is to identify unique profiles of adaptive functioning in children with ASD, and based on categorical item responses. And here, the scale we are using is a so-called Vineland Adaptive Behavior Scale, 3rd edition. This is just one of the most common, valid, and also reliable instrument used to assess adaptive behaviors among individuals diagnosed with ASD. And each item of this Vineland scale is rated on a 3-point Lect type scale that indicates the frequency of certain behavior, behavior related to the adaptive skills, for example, daily communication skills and living skills. And where a 0 just represent this behavior or like certain thing is never happening, and 1 refers to sometimes, and just 2 just represent usually. And this is kind of like how the data are collected, like what are the categorical variable that we are looking at. A really amazing part about the data set we're using is that it's really large. The participants we're using to achieve this cluster aim were drawn from the Simon Foundation Powering Autism Research for Knowledge Research Consortium. It's known as SPARC. And we are able to use the data that include more than 17,000 participants with a diagnosis of ASD and also complete the Vineland 3rd edition. The sample size is really large, which is really good for the analysis, since we have just more confidence to say the results can be reliable because we are using a really large sample. And the sample, not surprised at all, consists of more than 77% of males and just about 22% of females. This is very common in autism research that we have more males in the sample than females. Since we're focusing on the children, we also compute the mean and the standard deviations of the age of our participants. And the mean is about 9.43, and the standard deviation of age is about 4.12. And this is sort of like a like overall like introduction or overall information of the participants we are using in this analysis. So here comes the LCA results. So what we did is that we fit LCA with different number of clusters ranging from 2 to 6, and we extracted several model fit index, including the AIC, BIC, and G-square. And also we summarize the number of parameters in each of these models there. As you can imagine, as the number of clusters increase, we'll be using more parameters to model the entire population data, right? Because for each cluster, there will be a submodel involving certain number of parameters. And as we increase these little small models in our study, there will be like more and like parameters that need to be estimated in this. And as we can see from this table, apparently the model fit statistics just kind of like decrease as we increase the number of clusters, and also the number of parameters is just got increased along the way. And in addition to like summarizing the model fit statistics, what we presented here is the model predicted class probabilities. For example, in these two class cases, after fitting the model, we let the model to predict the class membership of the individuals we have in the sample. And it turned out that if we have two clusters, just like more than 76% of the individuals will be classified as one class, and the other 23% of the individuals will be kind of like grouped in another class. And we did the same thing for other models with different number of clusters. And for example, in this 3-class scenarios, we have like about 20%, like 17.3% of like children clustered as just one little group, and almost 40% of children clustered in another group, and the remaining 43% of children are sort of like in another class. And with a 3-cluster like solution, the class membership seems like more balanced. With that being said, the groups are more of like equal, having equal amount of like children there. And here's something for the 4-cluster where this kind of like distribution can be less balanced, and also for the 5 and 6 clusters. So we also try the HCA and on this like large sample, and to see how the individuals are like iteratively got fused together to create this dendrogram, which allows us to see how many clusters we need, and if we determine a number of clusters, how the individuals got grouped together. And this is the final dendrogram, the final thing. And as you can see from here, this just if we have fewer individuals, we'll see them more clearly. But since we have a really large sample, at the first few steps of the algorithm, the individuals are just grouped, are just kind of like together. And not until here, we are seeing a better, clearer structure of the clustering results. And if we want to retain 2 clusters, we'll be able to draw a line like here, so that we can kind of like have the population separated based on these 2 like lines. And here is a summarize of the predicted class probability based on that dendrogram we just saw. So if we retain two clusters, the first cluster, the first little group will have like almost 90% of the individuals, and the remaining 10% of the children will be in another cluster. And if we keep three clusters, it's sort of like break down the first part, like here, into like two smaller groups, with one of the group having 80% of the children and another group having like almost 10% of the children. And if we are like increasing the number of clusters, the larger cluster got kept break down to smaller pieces. Um, yeah. After having that results, another thing which is fun that we try to do is to see how the two approach agree with each other. And, and to look at the agreement, we kind of like test the agreement in class membership assignment. For example, when we are saying like we want to retain two clusters, like for example, and see how each of the individuals got classified based on two different approaches, the model-based LCA and also the non-model-based hierarchical clustering analysis. And it seems that with the LCA, like about more than 13,000 children will be classified as class number one, while the remaining like 4,000 children will be classified in another class. And we haven't explored the nature of these two classes yet. It's only representing the number here. And which with HCA and more than 15,000 children will be classified as cluster number one if like two clusters are retained, while the remaining 1,800 students children will be sort of like classified as cluster number two. And if we look at this confusion matrix where it shows like just 2 by 2 confusion matrix, we're kind of like saying along the diagonal that indicates the number of students who receive sort of like the same classification, who are grouped together. And there are quite a large number of students, children that are receiving the same grouping, the same membership based on the two approaches. However, what is something that deserves attention is this part, this 2,145 children, because they received different like class membership with different approaches. So with LCA, these 2,000 children are in different cluster with the children like here. But with HCA, they are sort of like grouped together with this 13,000 children. So this is something really fun that to look at, and also raise a methodological question regarding why the classification results, why the group membership are different for these 2,000 children, and whether it will be due to some like twinning stuff with the HCA algorithm, because we are using like one dissimilarity measure and we're using one link function. What if we're using different similarity measure and using different link function? Will the result be different and showing more agreement with the LCA? Or it is an issue of the nature of the data we have, because we have polygamous categorical data. The categorical data have more than 2 levels. There are studies that comparing the model-based and non-model-based clustering approach based on dichotomous like data, but there are just few studies comparing the agreement, these two approaches, like when the data have more than 2 levels. So since we don't really have a day to talk about this, I will just wrap up this presentation with a quick summary and discussion, and also a few next step like we're planning to do, and then we will have some time for a nice discussion regarding how do you like this sort of like thing, and how you think this sort of like comparison or approach can be applied in the field of education. So a quick summarizes that in this study, we compare a conventional model-based classroom approach with a machine learning, like unsupervised machine learning approach in identifying adaptive functioning profiles. And where again, the adaptive functioning profile is something that is receiving a lot of like attention in autism research. And to be more specific, we are comparing the latent class analysis with the hierarchical clustering analysis. The LCA may have limited capability in handling data of certain types based on its previous research. And the HCA, on the other hand, comes with the cost of lacking interpretability and also reproducibility. This is something people criticize about machine learning approaches, that it's more of like a black box, and you just throw in some data and it will give you some results. However, you never know what is truly happening in that black box, and how we as researchers, especially researchers in education, should understand and interpret the results. This is sort of like the major complaint or about the machine learning data-driven based approach. And a few interesting next step would be like number one, my colleague and I will just focus and take a look at the data, the results more closely to determine the number of adaptive functioning profiles and the nature of each of those profiles, which can be really challenging since that's going to involve a lot of like discussion going back and forth between clinical evidence and also statistical evidence. And of course, this requires the discussion with clinical psychologists, like the substantive scholar, and also educators who have more experience designing the intervention plan and also specialized curriculum. And from a methodological perspective, it's going to be crucial to compare and evaluate this conventional model-based classroom approach and machine learning-based approach, like under different scenarios. For example, different number of clusters, like different number of categories, and also different sample sizes, so that we can have a better picture or say guidelines regarding when to use what approach. And what seemed to me to be more important is that the discussion regarding the pros and cons of the application of both the model-based and non-model-based approaches should be happening. We should have this sort of like discussion, especially in the field of education. And having new approaches can be really fascinating, but we sort of like have to know what are the pros and cons and discuss like potential limitations of applying those approaches in our own research. So this is what I'm going to share today, something I am currently working on that involves a conventional model-based approach and a machine learning approach, and that focus in the field of autism research, autism spectrum disorder. And I hope you enjoy the presentation, and I will leave the time for Q&A and also some discussions.
Thank you so
And
much.
by the way, yeah, if any questions or any interest about what I'm doing, feel free to contact me using the email here.
Thank you so much for your presentation. It was super interesting. I'm just gonna open the forum for any questions. So please just go ahead or either raise your hand, unmute yourself, write in the chat. There's many ways to go about this.
Yeah, even though I would say, even though the context of my study is the focus of autism children,
Mm.
in the field of education, there are also so many circumstances that we have to like understand like the heterogeneity in the entire population. And with that being said, a more conventional, say, variable-based
Mhm.
approaches to understand the heterogeneity just involves modeling the variance, like the distribution of the entire population. That with this clustering approaches, what we are trying to do is something different. We are trying to identify like little like small subgroups within the larger population, which can be useful from a more practical point of view, since knowing the what are the small groups will allow us to do something specific for these groups, right? Instead of like doing anything for individuals. That's kind of like more inexpensive and more efficient way.
Right,
Uh,
right.
yeah,
And now it's such an interesting time that we're living where there's so much more access to running all these things, right? In like our
yeah.
technology allows it. There's a question on the chat. Hey Ju, sorry if I'm mispronouncing your name. I have a question about software for the machine learning. Which software did you use for running the analysis?
Oh, thank you so much for the question. You can for to run machine learning algorithms, you can just use R or Python. I guess both should be like super familiar for all of us here. And since there are so many packages that are sort of like well written in R and Python, so that we can run machine learning stuff. It really depends on which one you are more familiar with.
Thank you.
Yeah. And for LCA, you can use M plus or just R or Python. There are designed packages for the LCA analysis.
Hello. Good morning. I have a question too. Thank you very much for the presentation. Um, I have two questions actually. The first question is if in the dataset that you use, do you know if there's any or concern or eventually if you can suspect that the data could be biased in some way? Are you aware of like the discussions or limitations of the dataset that you used? And second, I wonder if in your data set you had access to demographics. I'm not sure if you could kind of like eventually interpret through those lenses
Yeah,
the groups that you were having.
this is really good questions and also very interesting next step. Sergio, am I pronouncing your name correctly? Yeah, number one, in terms of like limitations or anything I can imagine that could limit to that led to some sort of like bias in my results or preliminary results is that the categorical nature of the responses we have, since it's multivariate, categorical, and have more than two levels, the machine learning based algorithm could be some sort of like bias because we don't know what is truly happened. And as I mentioned in the presentation, for DHC analysis, we have been done, we focus only on one dissimilarity measure and also one linkage function. We haven't tried anything else yet. And research have shown that the choice of this similarity measure, like how far two clusters are, this is sort of measure will have an impact on the final results. And the same for linkage function. So a necessary next step for our analysis is also to look at like the impact of this similarity measure and also pick the measure that best fit our data. And regarding your question number two, I think that's gonna be a very important next step. And yes, we have access to the demographic information, and we also have some information regarding the cognitive ability, like cognitive damage of those children, and also the language level. So an important next step would be to incorporate those information into either the modeling-based approach or the machine learning-driven approach, so that we have class membership that better reflect the profile. And this gonna require some more investigation and a little bit more experiments.
Okay, yeah, thank you for the response. Yeah, because as I was like looking at your presentation, because in general, when you start to think about bias or any potential problem with fairness in all of this, you need to at least be sure that the measurement part is okay, and the test itself that you use is kind of, I don't know, like behaving reasonably. And it's interesting actually to see like how the specific task of like unsupervised learning for classification, how that can be affected when you have any potential problem in the test. Because
Yes.
basically you can, if for example the test is having some weird thing, and maybe you can detect that from the clustering, but if you interpret that as something kind of natural, maybe you are naturalizing something that is just related with the test, not necessarily related with the population. So yeah, I found that very interesting to kind of like think what's in what way clustering unsupervised algorithm can go wrong. Like it's tricky actually the way in which even like the way in which you separate two groups can the existence of a new category actually can be a problem depending on what you did wrong in the first step. So yeah, that's no, I found that very interesting.
Yeah, exactly. I totally agree with you that those approaches can be something that save our lives in some way. There are really new approaches, but I'm like sort of like still think we need to better evaluate this approach and then see when it works and when it is not working that well, so that we as methodologists could provide some better suggestions to researchers who are actually using these approaches in their studies. Yeah, thank you, Sergio.
Any other questions? I do have a nice question that I'm not sure if I'm gonna phrase it correctly because my mind is all over the place right now. But um, first of all, thank you again so much. It was so interesting, Asija. So interesting, all your research. I always, when I think of machine learning, and you mentioned this at the end of your presentation, how, it's kind of a black box, and we don't
Right.
know what's happening inside that black box. Whereas we have all these other methodological approaches that are more more grounded on theory, and that we understand potentially better. It's less kind of a black box. So what's your take on using these machine learning algorithms, as part of adding something to the research, to the IRT, type of
Mm-hmm.
methods that we already use, when we know that there's so much unknown of what's happening inside?
Yeah, thank you, Monse. This is a really good question that I don't have a good answer for it now. My understanding is that or say this machine learning based approach, they are apparently having their own advantages. For example, they allow us to handle like really large data set and can be really powerful in dealing with certain tasks. Um, and it can be a good replacement as more conventional approaches that has a theory ground under it. But for and it can also address several tasks that traditional approaches cannot be doing. For example, the automatic scoring. Conventional model-based approach can never do it to score an article, but an NLP algorithm, they can certainly do it. But as you mentioned, it's just a black box, and we don't have much ability to interpret what is truly happening and how certain things are grouped together and how the prediction was happening, sort of like that. We cannot do it. Yeah, so since each kind of like approach have its pros and cons, um, I think it's always a good idea to compare different approaches to on the same tasks and see which approach is better for certain tasks and when the results is more reliable and trustable. Yeah, sorry, I don't have a good answer for you.
I
Yeah.
appreciate that. No, I appreciate that. I think it's something that I myself am trying to understand, you know.
Mhm.
Well, if there's not any more questions, I'm gonna go ahead and say thank you so much for joining. And thank you, Sijia, for giving such an amazing presentation of this work that you've been doing. I hope to see you all next week for our next brown bag, and also I hope to see you in other events that the NCME GSIC is giving, such as the Viernes Social, which is going to happen next week, and we have many more things coming up before the conference. So just keep looking at the kind emails that Sergio sends and join us in our events. Thank you, CJ, again for everything.
Thank
And
you for organizing this. Nice meeting you all.
Thank you.
bye bye.